Hello everyone, and welcome to another episode of this stream with Luciano and
Roberto.
And as usual, we are here to do a little bit of Rust. And lately, we have been getting into Rust game dev, which pretty much means trying to learn a little bit of Bevy and building a very simple spaceship style, asteroid style game in Bevy. So, the funny thing, as usual, is that we like to compare what is the experience of doing these things in Rust and doing them in other languages that we are familiar with. For instance, Python. Roberto is a master of Python, by the way. And actually, we already built this game in Python. And in the previous episodes, we showcased some of this game in Python. And the funny thing is that this time we are doing the opposite. We are taking our Rust learnings and trying to translate them into Python. So Roberto did something really interesting, trying to recreate the same style of ECS, entity component system, that you have in Bevy, while recreating that game in Python. So he literally rewrote the entire game from scratch in Python, but copying, kind of rebuilding from scratch an ECS that looks like the ECS that you have in Bevy. So before getting back into Rust, we're going to look at this implementation from Roberto because I think it's pretty interesting.
So let's share my screen. Yeah, cool. Let's show again, starting from the final result of what we have. We have the game. If I run it, we have a slightly more primitive version of the one that we show in the previous episodes, because we are lacking the asteroids and the collision between fuel. But this is the current Python game, rewritten in Bevy style. Basically, we can collect fuel cell, we can go around, we can run out of fuel, and there are stars around. So this is what we already know and we are familiar with. What happened under the hood? Under the hood, this is now my main function, my entry point for my software. We are importing a bunch of core libraries. We are importing a bunch of core. Is my fake Bevy core. So the core is containing all the files that I used to mimic Bevy. There is a little bit of argument parsing. I start an application with a title and an FPS, number of frames per second, starting with 0. That is the default, means do as many frames as you can. I import all my components. The components are exactly what they are, the components in Bevy. They are struct. We can call them like that. Struct,
yeah, it's pretty much...
plus derive annotations and some stuff around it.
But if you don't remember what a component is in generic terms, it's basically the idea that entity is everything that makes sense in your game. But at the end of the day, the engine is only storing that as an ID. So it's just trying to keep track of different entities. Then every entity to have a meaning, you attach components, and you can see components as behaviors, like, I don't know, health system, position in the screen, velocity, anything else that makes sense in your game. If it's jumping, or if it has a sprite, if that sprite has a specific animation. And you can have physics engines that will add other things like, I don't know, a rigid body property. So a component is literally any property that you might want to attach to an entity.
So just a question, is the font big enough, Luciano, or is better a little bit bigger?
Maybe give it 1 point of zoom. Okay, that should be all right. Let us know in the chat if it's not readable.
Okay, so my main is this. So this is just to make the window centered when it starts, and this one is uprun. Uprun is a little bit different from Bevy. In Bevy, you have to specify plugins, set up systems with a chaining of calls. Here I use the decorators. So up setup, it means that this function is called at the setup of the application, and it takes a command as a parameter. With this command, annotating the type that we want, and this command comes from the core command here. Commands, sorry. We spawn our star, we spawn our fuel, and we spawn one ship. As you see, the insert is similar to the Bevy one for version 0.9. It takes a list of stuff to add to this entity. So command spawn give you an entity, give you back an entity, and then you can insert in this entity a list of components. That can be any. This one, the star, is just a sprite of a star. Fuel is a sprite of a fuel, is a velocity, and a fuel entity, a fuel component, sorry. So this entity is made of fuel with a random capacity 1 or 2, a velocity, and a sprite.
When you use sprites, you are still using the Pygame ones, right?
This one is my sprites that are here in this folder called sprites. Inside this one, there is a class that is still using the Pygame sprite. And here I have to have my own sprite class because I have stuff in common between all the sprites at the moment I copy and pasted. So one of my to-do is to make my common class. Also, there's another to-do here, move to a transformer component, because the rotation and the center of the sprite is not in a transform component, but it is in the sprite itself. So I'm not completely there yet. So these sprites are my sprites that, yes, they inherit from the Pygame sprite. Then my ship is made of a starship that has a 100 that is rotation speed, velocity in X and Y, engine with fuel thrust, fuel efficiency, and this on. Here we have fuel efficiency. We don't have that in Rust because for some reason the numbers are not matching up, but basically is how much fuel you consume while you thrust. In Rust, we kept them to one-to-one conversion. In Python, if I do the same, I run out of fuel in 1 second. So I had to multiply by 10, basically, the efficiency of my thrusters. And we have, obviously, a sprite for the ship. So until here, the only strange stuff is this injection. I mean, you annotate this in Python, and you get injected the commands, an instance of commands. Commands come from here. It is a class that has a spawn, give you back. Basically, this is a singleton. I implemented this as a singleton. So all the system and setup have the same command passed back. So it's calling we can call static function here, that is creating a new entity, adding it to my entity list, and returning it. I have a kill to remove the entities when I collect the fuel, and I have a get all entities that is basically giving me back this list when I have to loop on top of them to have in the query I need it to filter on top of it. So let's look at one component. For example, the starship. This is our component starship with a rotation speed. This is very similar to Rust. There was a struct called starship annotated as a component that had a rotation speed. Engine, the same. We have a data class that has a bunch of properties. And here we have this decorator and a system called rotate speed. This system is like the system that we have in Bevy. It takes a time, if there is a key pressed, and a query of ship and starship. So I'm giving back in this query variable all the entities. They have both a component called ship and a component called starship. I admit that the naming is not splendid. This ship is the sprite ship because it comes from sprites, and this starship is this class, sorry, that comes from here. I still have to find a better way of naming stuff. This can be ship sprite instead of just ship. But I mean, delta is the time delta second. This is exactly like Bevy. This is giving me the time passed between the last call of this function and now. So basically the frame time. If key pressed Pygame, I still use the constant from Pygame under the hood. If I have pressed the right button, okay, then for all the sprite and starship in query, sprite and starship. So even here, like in Bevy, when we loop on top of the query, like in Rust, we loop on top of 2 elements. This was the bug print. ship sprite set rotation to the old rotation plus the rotation speed multiplied by the delta modulo 360 to avoid to. So here I kept the rotation as a single value, not like in Bevy with all the quaternion and the vector stuff. I kept it a little bit simpler. For the left is the same. I loop on top of all the results of the query and I apply the rotation. The engine on is another system that take time k pressed k up because I want to know when I release the thrust to turn off the animation. And then the math is very similar to the one that we have in Rust. Here there is a difference. Here I'm not looping. Here I'm doing query.first. So I'm taking the first result of this query. In theory, it should always be only one because with a velocity, a ship, and an engine, in theory, we only have one stuff. Here I could have added the starship. Well, and then
I'm really curious to see how you implemented that query.
Okay. Query is implemented. Sorry. Oh, up to it. Thank you. So query is implemented like this. When I create it, when there is this stuff here, basically this is interpreted and executed when this function is parsed. So query is giving me back an annotation, something that is callable. So it gives me back a query instance, remembering which object I want. When I will be here calling the system, I will show you later the decorator, how it works. I will call what init get back. So I will call this instance. And when I call this instance, I just give back myself. So I'm passing through. Then when I have query, I can do a for on top of it. So when I do this for up here, I will go in this iter. Iter is preparing a generator that will do for all the entity in commands get all entities. Is preparing a result. Here I have optimized filter with maps and entities. Now is a linear search. It's not very fast. I can optimize it, but this again was a proof of concept, so I started simple. For all the entities, if the entities has all the stuff I'm searching for, or the S I'm searching for with an is instance, then I add this component to my return structure. If I ask it for free types and I have all three of them, so if the length match, it means that I can yield this element and that will be one of the filtered entities. If they don't have all the element I'm searching for, I'm not yielding, so the generator will not give you anything.
Okay. And this is how you can destructure all the different components because that Y is basically the collection of
this Y is what I'm yielding.
Okay, the current entity which has all the requested components.
Exactly. Is a copy, is not a reference. So even here I can optimize and make it by reference and not by copy. So the component are by reference, but Y is an object, is a new object. This can be a tuple. There are better ways of doing this, but there is a to-do for me to optimize all of this. Instead, when I call first, it's just this function first. So I loop on myself and I return the first element when I loop in it. If I don't have a first, Python is giving me back a known, and this will throw an exception. So if this query doesn't give back a result, when I do first, it will just throw an exception. And get item, I don't use it here. I don't remember where I use it. Probably somewhere else. Oh, query, not even here. Okay, I don't remember why I have it, but this is basically to have the ability of saying query square bracket 0 and having the first of the components. Square bracket 1 and having the second one, just to address them singularly, instead of doing this assignment to destructure them. instead of doing this, I can do query of 0, it will be velocity.
Yeah.
I can do query square bracket 1, it will be the sprite ship, the ship sprite, sorry, and query square bracket 2, it will be the engine. So, but it's just a matter of easy of use. And even there, I can optimize a lot. What is interesting, or what I did, is how the system decorator works. The system decorator is this one. So when I annotate the function at parsing time, Python is annotating, creating a new version of that function. The original function is passed here. I'm creating a new function that will replace the old function, passing the parameters. Which parameters are passed to the original functions? This this KV list. KV is a map that is destructured, so it will be, they will be called by name, and is taking the annotation that I have on the system. So when I am here, is taking this annotation time, and is making an instance of that time. So every function will have a different time instance. They will all will have a time instance, but all of them will have a different time instance, except for some of them that are implemented as a singleton. And basically, to implement them as a singleton, I just leverage the fact that in Python, a module is basically a singleton.
Mm-hmm.
Because you can import them as many times as you want, and you will only have one instance of them. And here there is inspect the signature of the original. So here I'm doing reflection on the original function, getting the parameters, taking the items, and then just calling them in the same way, but instead of keeping them as an annotation, I pass an instance of that class.
Right.
Here I'm calling the original function, and here I'm adding the new function to the underlying system, that is a list of all the systems that are registered. So at every loop down here, I do for all the functions in my registered systems, I call them. And this will automatically inject the right parameter and the right class in the right place.
Nice.
And this is part of my core class. So I think this is all the magic that there is under the hood to mimic what Bevy is doing. Mm-hmm. Obviously, I left a bunch of to do in the code because there are stuff that I have to make variables. I have stuff that I have to improve. I have to remove magic numbers that are yeah, I know that this has 4 frames of animations, but I hard coded it. It's not exactly the best way of doing so. What else? Oh yeah, I'm making a transform component that now is merged with the sprite itself, and probably they could be each different type of entities to separate the domains. So this was a little bit of refactor I had in the back of my mind for 2 weeks. I had finally time to do it, and I like this approach that Bevy has to, okay, query this, give me this, I will work on these entities. Obviously, there is a little bit less code to write because Python is a interpreted language and not compiled one, so I don't have to understand everything at compilation time.
Mm-hmm.
And everything is mutable, everything is by reference by default, and so yeah, it's like a little bit different.
You didn't have to do a query engine with generics, right?
Yeah, exactly. Python instance of, yes, cool, yours.
Okay, should we switch to Rust?
Yeah.
By the way, feel free to ask questions in the chat. So if there is anything that doesn't make sense to you, we can discuss that.
All of this is in the repository in Luciano's GitHub.
Yes, I'll need to find it and share it later. Okay, so let's see if this thing runs. First of all, it might take a while because I installed a new dependency, so it might need to recompile. Oh, I'm not switching the screen, sorry. That didn't make any sense. Okay, now you're seeing my screen. Okay, so basically what we want to do, last time we built pretty much the same game that you saw in Roberto's Python version. You can move the ship, you have these fuel cells floating around. When you move the ship, you are consuming fuel. But if you collect fuel cells, you kind of restore your own fuel and you can keep going. But right now, there is no way to die. Basically, the worst that can happen is that you run out of fuel and just keep floating in space. But there is no enemy, nothing that can kill you. And what we want to do is we want to introduce asteroids. And asteroids are just randomly floating in space. And if you hit them, you're just going to explode. And that's the end of the game. So, in order to create asteroids, in one of the previous episodes, Roberto showed us piece of Python code that can programmatically generate a shape that is an asteroid, but it's like a little bit random. So it can have, I think you did like 5 or 6 sides, but this is not like a regular polygon. It's just
between 5 and 8 randomly, and also the points are randomly distant from the center.
Mm-hmm. So what we were doing, right? So what we were looking at last time is how can we do the same in Rust, in Bevy, and unfortunately Bevy doesn't support yet a way to define a sprite that you can programmatically draw into, or at least not that we could find. But we bumped into this library called Bevy Prototype Lion, I guess, or Leon. And basically what it does is it basically gives you this feature. You can create a sprite, and in the sprite you have a surface with programmatic APIs, and you can use it to draw your own custom shapes. And by default, it supports regular polygons, so there are methods to create triangles, squares, pentagons, and so on, which can be an option. But if we want to do something custom, I think you can also do like a polyline. So we could recreate the same algorithm that Roberto showed us a few episodes ago. Now, how to use this thing, we don't know. I guess we have to find out. The only thing we did is just installing it, and as you can see, it's taking forever to compile. So while it's compiling,
as usual,
exactly, this is actually the annoying thing with.
We could try to create a random asteroid at the center of the screen without adding the impact with the ship for now, just to see we can draw it.
Exactly, yeah.
And to draw it in the examples in the library under example, there is a dynamic shape rs file.
Let's see, there it is.
If you scroll down to the very bottom, there is a draw mode outline. You see?
So they do a setup system where they spawn a new geometry builder, build as, draw mode outline, fill mode. Okay, outline mode. How do they define the list of points or segments?
What is that shape, the first parameter?
Oh, it's a reference to, let's see.
Okay, but that is regular. So we want it in regular. But well, we have to find a way to make the shape with irregular stuff. It was some lines above in line.
Oh, there it is, regular polygon. Yeah, okay, we can probably check the docs and see if we can find anything useful there. Crates.io, there is documentation. Okay, geometry, I guess, or shapes. There is a geometry builder.
Yeah, that is the one that is used there, but still we need
something that implements a geometry. How do we define a geometry?
Is the shape that I care about, I think. Try to go back to the root of the documentation. Try to shapes.
Okay, circle, ellipse, line. Regular. There is a SVG path shape, which can be good.
There is a polygon that is not regular because there is a regular polygon. So what we need to give points as a vector of vec2 enclosed, exactly like Pygame.
Perfect.
You have to give them a list of tuples of 2 elements, and tell with a boolean if you want the path closed or not. So it's the same exact stuff as Pygame. So we can
Perfect. Meanwhile,
create
here has
polygon shape.
compiled, and you can see the game running. So you can do stuff. This is still
In the
working.
Python one, I also have the stars.
Oh yeah, we can add stars as well if we have extra
But in
time.
this one, you have collision between fuel that I did already.
And they also spawn new fuel cells every time they collide.
I'm still behind, but I will catch you.
Okay, do we do a new file? Let's do asteroid. And we need to add it in mod asteroid. Maybe this is too small. Let me make it bigger.
Yeah, it's fine.
And then
okay, mod. Oh yes. I still have to get used to this.
Yeah, it took me a while to get used to it.
Because in Python I have no problem import this dot relative absolute imports, but with Rust I'm still catching up.
Let's copy something from here. Right, what do we want to do? We want to
an
do
asteroid,
a struct, right?
An asteroid. I mean, you can have it empty, like they do in that example for now.
Exactly, it doesn't have to.
I think for now doesn't have. When we compose the entity, we need it. We need the velocity because it will move around, but not now. Now we don't need it. So
and it needs this. We can add Bevy prelude.
we need to add the instructions where we spawn all the stuff. That is in where do we want? How we structured the code? I don't remember. Do we spawn the stuff in the file, or we have a single setup function?
We created an helper function for now. Actually, I was looking at some other Bevy projects online, and people tend to create plugins for every one of this file so that they can easily just install that plugin, and that plugin takes care of also spawning stuff for you.
Okay. So you will create an asteroid plugin instead of just the component, and then when you add the asteroid plugin, it will spawn the right number of asteroids and all the other stuff.
And systems and so on.
How do you share, for example, velocity? That is a common component for a lot of these.
Here we did a common thing. So I suppose that could be one way, but I still need to look for more projects and see what other people
understand. Okay. So for now, we stay with our structure.
Exactly. We can copy this thing like we did here, spawn ship, right? At the end of the day, we just need commands. So, and we call it spawn asteroid.
And then we call it from our setup.
Exactly.
Somewhere.
Now we need to see how to initialize that plugin, which I don't remember. So let's check. Where is it here?
Search an app in the file. There will be an app.
Oh, we have a new gift, a new subscriber. So thank you, Edible Monad, has gifted one subscription. So thank you for that. Really appreciated. So where are we? We are doing this guy. So we need to use the prelude. So let's do this in the main, where this is something again that we could do with a dedicated plugin, but as we did for the inspector eGUI, that the debugger bar that you saw on the left side of the game. For now, we are just doing it in the main. So kind of global extensions for now are all in the main.
Why prelude?
So prelude is another thing that is quite common in Rust. It's basically when you have a package that exports a bunch of types. And generally, when you use this package, you need to import many of them. They do this thing that they create a prelude, so you can just import that prelude and you have all the defaults, basically. So it's kind of a shortcut. For instance,
Okay.
in Bevy, Prelude will contain component, commands, camera
Okay.
2D, like all the more common things that you will probably want to use straight away.
Okay, understood. Thank you. So now we have to add the plugin in line 23.
In add plugins, which is, where is it?
Shape plugin.
Oh, this one. Yes, you're right.
Yeah, shape plugin.
I was looking for something like lion or leon or
Lion. No,
whatever.
it's just called the shape plugin. In our line 22, where is it?
Where do we do add plugins?
Line 22.
Here we have the word inspector. So
Yeah, but
let's add it here.
it's not in that chain of code after the add plugins with the plural, or we can go even before. Does
Yeah,
it
why
change if
there is plugin and plugins?
okay,
Oh,
because
because this needs
plugins
to be a group. Perfect.
is a group of the default ones. Can we go
Let's
before
add
or we
it
need to
here.
go
Yeah.
after? Okay,
Just in
just
case, let's do it after, but I
let's play
don't
it
know.
safe.
Exactly. I don't know if it makes any difference. Okay,
Play safe.
now whatever this plugin is doing, we have it enabled. So we can try to
Try to copy and
let's
paste
see.
what we have in that example in our spawn asteroid. That will be wrong, by the way.
This regular polygon, right? For now.
Yeah, and then we change that shape to something else. Yes, take that one.
I think just this one will be fine. Okay.
You can. You can take also the geometry because probably it's needed also.
Okay, now shapes, where is coming from? Oh yeah, we need to use this thing also there because it's giving us the shapes.
Yeah.
Now shape is
Now,
how
if
do
you
they
do, they do command spawn geometry builder. Don't look at the camera. The command after the camera.
this
Copy
guy?
the spawn after. Yeah, copy all that spawn. Cool.
Perfect, okay. And it should be cyan and black. Let's do it white.
Yeah. We can
Otherwise
change
we are
it.
not gonna see it. Okay, now we can call this
Uh,
function spawn asteroid.
yeah, from our setup.
Yes, let's just do it for now in our setup function here.
What is the
Spawn.
setup that spawn the ship?
We did it here. Spawn ship. So we did a startup system.
You add that one as a startup system? Spawn asteroid is not a startup system.
Let's do. We need to create another function. Or is it the
That
same?
one
No,
is.
it's the same. Let's do it this way.
You can use that one, no?
Yes. Up to stage.
Copilot today is not helping you.
Today is not helping. Why doesn't like it? Asteroid singular. Definitely not helping. Okay, let's see what happens. Cargo run. Are you confident?
But we will see something. Probably not what we want.
Are you confident we'll see something? Yes, nice.
Yeah. A little bit too big.
Looks kind of cool. Okay. Cool. So now we can. What can we do? We can try to
make
change this.
the shape to a random one, and
Mm-hmm.
also make it a little bit smaller. With the
Okay.
inside black and the border white is fine, and less thicker board, but well.
So if I remember correctly, let me go to a drawing page. Your algorithm was something like this. We have a center.
Yeah.
Imagine that this is our sprite, right? We have some boundary.
Yes.
Then what we do, you can imagine that we need to decide how many sides we want to have.
Yeah, and so
right?
we choose the vertex number that is the same as the sides between 5 and 8. We can do 5 and 10 if you prefer. Right?
Yeah, we can randomize, but let's say for
And
just
then
as
we compute an angle. The angle from there is 360 divided by that number. So, and we start there. First point, random distance from the center between, it was between 16 and 32. But here we can change the numbers.
Okay, so let's just make a dummy example. Let's just say for here, just as a random
we
thing,
start at 0.
that we go with four sides, just for
4.
simplicity. So we start
Do
at
5.
0. We need to pick 1 year, 1 year, 1 year, and 1 year using a random radius between year and year.
Direction, their direction is that one. So 0 will be 0, 90, 180, 270. But the distance will be random every time. So at that point, you will have
basically we need
4 random points. Yeah, let's say that you take 4 random distances.
So we need to pick 4 random points, for instance. One goes here, another one goes here, another one goes here, and another one goes, I don't know, let's say here. At this point, we can draw our shape.
We connect them, yeah. With 4 is not that beautiful. If you start with 5, you have this pentagon, irregular pentagon that is
so if we
nicer.
do with 5, let's say that we start here, right? Then how do you split in 5?
It's 72 degrees.
A little bit less than 90, so let's go here. For instance.
72, so a little bit
then
less than 90.
Something like this, something like this, and let's say this, right?
Yeah, and then you connect them.
And then you connect, and you have...
They can even be convex, because if you throw a distance that is quite short, it will go inside.
So we want to implement this algorithm that eventually needs to give us the segments, and this way we can draw every time the game is running and we spawn a bunch of asteroids. They all look a little bit different.
So all asteroids will be different, because we have to call that spawn asteroid, I don't know, 10 times.
10 times, yeah. Okay, so let's try to do that.
Let's try to do one asteroid.
So let's do, first of all, const asteroid, or just sides, because this can be private. What is the bounding box? 32? Does it look okay?
What is now? Radius 200. Yeah, let's make the maximum distance 32. Then we see if it's too big, we change it. But let's go with 32 for now. If it's too big or too small, we change it.
Let's see how it looks right now.
You changed it just directly that. Okay.
Too big?
No, I think it's fine. Whether it's the ship below it.
Just below, yeah.
Yeah, I mean, they will be in average smaller, because if we throw a random between, I don't know, 16 and 32, so between the half of the size and the size, throwing a random, at max they will be that big, but it's almost impossible that they will be that big. They will be a little bit smaller. But we can make it 64 later if you prefer. It's just a number. Let's start with the algorithm.
Let's start with that. Okay, now let's review what was that method that we saw. So basically, we need to produce a vec of vec2.
A vec of vec2.
Okay, and these are all the points that we need.
And these are all the points, yes.
Okay, perfect. So what we do here is, let's create a random function that fn generate
random shape,
and
it takes a number of points, size.
Or we do it totally random.
Yeah, okay, let's do random inside it.
And the size is also, we use the constant. So what it's gonna return is, do we just return the geometry at this point, the polygon thing?
So the shape.
Yeah.
Okay. the polygon itself. Yeah, we can return the polygon.
So basically what we want to return is this. Well,
we have to compute the points.
Polygon. Let's do points first. So let mute points equal.
Can we do that? Can we do that with a list? Not. It's not called list comprehension. My God, how they call it in Rust when you chain in a functional approach. A functional approach. Can you do something like a random between 5 and 8 dot and then each?
Import polygon from shapes polygon. Okay. Cool. And now it's understanding this is a vector. Okay, so let's do let sides, right? And this is random. That's interesting.
That is random between 3 and 10.
Let's go between
5.
5, and this goes to what, 13?
7, up to 7. So 7 and 5 is 12.
Oh, because this is a U8, so it's 200.
Yeah, but it's modulo 8. Modulo 8 can only go between 5 and 7. 0 and 7, sorry.
Okay, plus 5 goes to,
plus 5 to 12.
12.
So if you want less, you have to try a modulo 4 is enough. Modulo 4,
no, I think this is fine, right?
Okay, let's go with it. With that.
Okay, now what do we need to do? We need
I was in Python, I was computing the theta, the angle.
But we need to do a loop, right? We need to do for every side.
Yeah, but the angle is you can compute it only once because it's
right.
The angle is
theta equal. Do we need to do it in radians or do we do it in?
I think we need to do that in radians. So it's 2 times pi sliced the number of sides. That is what is suggesting you. Yeah, so it's suggesting you the
nice one. Okay.
Now, for I, because we need also the number in size time. So
okay, for okay, this is starting to look interesting. So for every I in 0 to sides, so that looks promising, or is a random that goes sides divided by 2. Yeah, so it's actually random.
Yeah, we want the sides and not sides sliced 2. We just want sides and we want
but we are starting from the center, right?
Yeah.
So we want the sides divided by 2 or not?
No, right now we are doing a radius 32. It was that big.
Oh, okay, I thought that 32 was the entire sides. I didn't understand.
At this point, I think 64 is the entire size because it's
yes,
a radius.
You're right. Here is radius. Okay, so let's do 32 as the full size.
Don't split it by 2.
Then we call this radius. Sorry, we call this. What do we call this?
Max radius, if you prefer.
Okay, I was thinking more in terms because eventually we will need to draw it as a sprite. Do we?
No, I think it's just
draw. It doesn't matter. Okay, then let's just call it max radius.
But the Copilot suggestion was good.
Let's see if it's still max radius. Now it's even understanding it doesn't need to be divided by 2.
Yeah, but for I in, we need I. How is doing without I? Copilot is doing magic. Yeah. Sites. Okay.
Okay. Points.
Okay. Yeah.
Okay, that looks good enough. Let's try
now. Yeah, now our radius doesn't have a min, can be 0, our radius. If you don't like the shape because it's too irregular, we have to add something to it to make it a little bit bigger. So we need a min radius and a max radius. But let's look at how it is now.
Mm-hmm. So basically, if I understand correctly, we need to replace this with a function call. That should be it.
No, we have to not use a regular polygon, but we have to use a shapes colon polygon. So it's different. You see shapes, your line 29. Mm-hmm. Change a regular polygon to polygon, and then it will change the number of parameters.
Oh yeah, but this is already a polygon, so we replace all of this?
No, it's not. Is a polygon, that one?
It's already shapes polygon.
Go back to the documentation a moment. Go one back.
The one where we were looking at the...
No. The documentation, but one tab before. Go back with the history. Polygon. Okay, yeah, we have to replace the wool polygon with that. Yeah, okay.
Okay, so we replaced with this.
That is a polygon, and then build as is fine. Is happy with that.
Shape, and we can specify the outline mode.
Yeah, white. Yeah, just change line width to 2, not 10. 10 is, I don't like 10. And the color inside, you can make it black, because black is better.
Okay, cool. So it's similar to what you had the last time.
Yeah, except that it will be a little bit more irregular, I think, because we don't have a min radius. Our min radius is 0. What is it?
It's totally flat. Now, did we get unlucky, or it looks like a scar, like a scratch?
Okay, let's review the code.
Let's rerun it very quickly, because maybe we got...
no, we don't increment the angle.
Yeah, that makes sense. So we are drawing over the same line
is r. Then you have to multiply theta by I. Multiply theta by I and then call cos. No, you have to multiply theta by I before doing the cos. So theta multiplied by, but in round brackets. So we do the cos on top of, and the same.
Do we do the same here, right?
Yeah, there. Okay, yeah. We are just not going around. We're just always there, and It's complaining about what? Because I is an integer. Yeah, sorry. F3 is a very small float.
3 bits. Okay, now it looks a little bit better, I guess.
Yeah, now it's irregular for sure. Can we spawn in random positions 10 of them?
Yes.
I think this is irregular enough. We can change this later. Now, can we spawn...
let's just call it spawn asteroids. So I'm going to rename this guy.
How many do we spawn? Let's make a constant. 10.
Good question. Let's do...
He's listening to me. I say the 10. Okay.
Yes,
he's listening.
It's scary.
I'm quite worried. He's listening.
Okay, so how do we add the transform?
Transform default. You have to change that transform default to not a default. So what parameters transform have?
I have no idea.
Transform, and then you use the curly brackets. And
the way we do it. Yes, translation scale. So let's do...
Keep everything, then we change it. Yeah, this is random. But it's random... it's good, but it's for an 800 by 600 screen. We need to inject in the setup the screen size.
Yes.
We did that for the system that
I don't
handles
think
the
we
ship.
need the scale if we are doing default. Yeah. I mean, the default scale should be 1.
I hope so.
Okay, let's see what happens, regardless of the sides.
Yeah, they will just probably stay in the center of the window, because we have to pass the system. We have to pass the component to get.
Okay, we have a
there
bunch of crap scattered around.
Yeah, because we don't have a min radius. I would like to add a min radius if possible.
They look interesting. Look at this guy. Looks like a boomerang.
Randoms
Okay.
are randoms, guys. Add them in radius. Then we can. What do you want to say? 12, 16?
12 sounds
12.
decent.
So now
how
what
do
is
we...
there? Now it is the random multiply the max radius minus min radius. So you have to put the round brackets around it, because they must multiply the difference.
Plus min radius.
Plus
right?
min radius, yeah. Exactly. Now this should be a little bit less ugly. We can add here velocity here. Yeah, this seems a little bit more like mines now.
Okay, it's also interesting that they
You don't
right now.
They can overlap, and they can crash the ship at the start.
Yeah, we can spawn them in a smarter way later.
We have to spawn them at least far from the 0, 0. Math. This is math. So we can do it later. Now, add a velocity to them.
Let's see. How can we add a velocity? Because we want to...
Where is this? Scroll down. When you add the transform,
when you
add
do
a
a
velocity.
spawn, you can also add insert. Was it like that?
But you can't add the velocity.
No, because you are... So this is a bundle, I guess. That they, with this builder, they're probably generating a bundle.
Okay. So we have to insert a velocity that comes from
our own thing. Did you figure it out?
The numbers are totally wrong. We do velocity differently. Can we have a default constructor to set a random velocity?
Import create velocity. Can we have a constructor in velocity, you mean?
Yeah, for the fuel, what we do now for the fuel when we instantiate the fuel velocity. That this is when they touch together, but there is a moment. Okay, I will just go with the same function, but at this point we have the function in 2 places. Can we just do velocity?
Yeah.
Velocity : random. I don't know. Can we define a function called random in the velocity that give you back a velocity with a random value?
Of course.
I think your answer is yes, because you are writing it.
So we can replace it here. :
rand. Nice. And also and do this also in the
asteroid.
Insert.
What am I doing?
Line 49. Call the function instead of. You can, and now you don't have to call multiple insert with 0.9. You can call one insert with multiple parameters.
As a tuple, yeah.
In Bevy 0.9 you can do that. Okay, but it should work also in the old 0.8 way, right?
This way, I think, is more universal, yeah.
Okay, let's try it. I think we updated the other one with the tuple when we did the upgrade.
Let's see. It's thinking. Okay, they move. Nice.
Now we should make them not start over the ship nicely, and we have to handle the collisions. That now they just will pass through. they are not really there. And they don't
Also,
touch each
not
other.
too sure what's the Z index.
But well, for the ship, the Z index is not important. I mean, if the ship touch the asteroids, it explodes.
Yeah, that's
So,
fair.
and for the fuel, yes, we have to choose now what happened on all the collision. Fuel with asteroid, fuel with fuel, asteroid with asteroid, ship with fuel. We already did that. Ship with asteroid, it explode. So now we have to define all the what's happening when.
Mm-hmm. Okay, so what do we want to do first? Collisions between the ship and the asteroids?
Yeah, for now, yes. Then we can do collision between asteroid and asteroid and choose what to do. If they bounce, is interesting because there is a little bit of math involved that I didn't prepare. So
Mm-hmm.
we can show how
Okay.
bad we are at math.
Another thing that I'm realizing is that we don't have any stage right now, meaning that
What
we
is a
don't have
stage?
I'm calling it stage. I don't know if it's the right way of saying it. Like, I don't know, you have start the game, click to start, then game
Okay, we
mode,
don't have in Pygame. I think they call it scene.
or maybe it's called scene also in Baby. So if we crash,
I
what do
don't
we do
know.
for now? We just do an animation and that's it. Then we'll figure out
The
how to do a
Python
game over and reset later.
The Python one is setting game over, showing game over, destroying the ship, and everything else continue to move because. And when you click R, and you are in game over, it restart calling again
Mm-hmm.
the init function. But yeah, all the managing of transition between pause screen, levels, that kind of stuff. Does Bevy have something out of the box, or you have to implement that on your own?
So as far as I'm aware, this is something that it's under discussion. Like there is
Okay.
a mechanism to basically attach system if certain condition happens. So you could have like your own state management and then you say like this system exists only if this other condition is true. And then you
Mm-hmm.
can do if I am in state splash screen only show the menu. If
Yeah.
I am in state game over only show game over. Something like that.
In Python is funny because you can do that in the decorator. When you do the app.system, you can do app.system, open curly brackets, and you add the tags, and then you just use a system based on tags. And the tags can be, like you said, main menu, game over, level 1, level 2, level 3, and so on.
Nice. Okay, I was reading also that there is an RFC to change the current mechanism because apparently in Bevy, when you do it like that, it gets very complicated very quickly because literally you need to keep track of all the systems per state and do all this accounting yourself. So they were proposing something else called loopless, which I think has been approved, but right now is only available as a plugin. But I haven't really spent too much time looking into the API, so maybe something we can do next time.
Okay, so now we do collision between ship and asteroid, and what we have a sprite for the explosion, but if you say that you were looking for a particle
That's
plugin,
another thing we can look into, if not today, next time. Let's do the collision first. I mean, we can just
okay,
print in the console, right? Collision for now. That would be
and
good
destroy the
enough.
ship.
And despawn the ship, exactly. How do we collide? Because we can use the thing we used last time, which is literally a bounding box, but basically it wouldn't be super accurate because
It's true that we don't have the perfect pixel collision in Bevy.
like for
That
instance
is
here I would have been
interesting.
already collided probably like going around this guy.
Because for the fuel, we went with the distance, right?
For the fuel we went with the distance, yes. Like
So you are collecting it even if you are slightly away.
mm-hmm. And between the fuel and other fuel we went with something like bounding box. So if the squares are overlapping, they will do the collision effect.
Interesting. I forgot that we don't have that in Bevy. How can we do that?
Oh, look at this. It looks almost like we already implemented collision between. Okay, so I don't know. Maybe I wonder if we can. Yeah, it would be probably a lot of maths in the asteroid itself. We can have a function that is like if the bounding box gives you true, then you can check more in detail. Is it really colliding or not?
Right.
Or for now, we just implement the bounding box and that's it.
Let's implement the bounding box because it's an interesting question, this one, because, yeah. But let's go with the bounding box, long story short.
Okay.
And then we can think of something for the next stream.
Sounds good
How
to
do
me.
we compute the bounding box or the circular distance of that? We just go 32 by 32, no, 64 by 64. That is the max size. Okay,
Yeah,
let's go with
against what was this one, 24 or something like that?
But well, we can do a radius collision, so a distance, because we know that the asteroid tends to be circular, and the max radius is max radius.
That's a good point. So you have a little bit of freedom around the edges, which
Yeah,
may be a
obviously.
little bit more realistic. Yeah.
Okay. Let's try that.
Sounds good. So
we have also to take in account the space of the ship, because the ship is not a point. But how big is the ship again? Probably we have that number in the fuel collision system.
We have it here, ship 32.
Okay. And are we using that one in the fuel collision? Can you show me the fuel collision again? Probably in fuel. I don't know.
Is it in fuel? Spawn fuel cells, fuel cell collision system. This one is between themselves, so probably we did it in ship. Collide with fuel system. There you go.
Distance is ship transform translation distance, and then if the distance is less than half of the ship size. Okay, so probably we have to say if the distance is for the asteroid, if the distance is less than max radius and half of the ship size, we have to put them together, then collision. So we can copy basically this function and changing a bunch of stuff.
Sounds good, and I think it makes sense to keep it in the ship. Then if we do collision between asteroids, it will be in the asteroids.
In the asteroids, yes.
Okay, so the query is and
we don't want the entity. Sorry.
Because they don't need to despawn, right?
Yeah, they don't explode. You explode. We need an asteroid.
And we can just do a with asteroid because we don't need any property of the asteroid.
I don't have implemented this in Python, for example, yet.
Then ship query is we don't care about the engine. We just want the entity.
We want the entity. We want the entity because we have to dispose of it.
And the transform, we need it to read the position and the size.
Yeah, we need it for the position.
Now, does it need to be mutable?
What?
This guy.
We have to dispose the entity.
Why is it complaining? Is entity with an ampersand? Is it? How did we do it here? without, so I remember correctly. So what's the problem there? Oh yeah, I forgot a angular base.
Ah, okay. Don't where?
And this one doesn't need that.
Yes, there. Sorry.
Okay, that should be enough. Now, we
first
might
parameter-
need to make this one public. Can we do a constant public? Yeah.
Doesn't complain.
Okay, so
Now
the first
we have
parameter.
the
We don't need the
asteroid.
engine. We have
Yeah.
ship, a ship transform, and we remove this guy. Then here we just have asteroid, let's just call it. It's the transform, we know that.
Yeah, and change fuel query in asteroid query, otherwise. Okay. If distance with the asteroid, not fuel transform, change that fuel transform in asteroid. And that should give us the distance.
And now,
if the distance is more than max radius, you have to import it somehow.
Let's see what it does.
Plus
ship size divided by 2.
Yeah, that's fine. He's not complaining. He's seeing that all good. Okay. Commands
He's
entity.
Complaining. So we need to use create asteroid. Can we do asteroid
and the max radius?
That's gonna work? No.
The max radius is a constant at the same level of asteroid or not?
Right, so what we can do is create asteroid max radius. No? I thought we could do that.
Go in the mod RS.
Oh, there is game asteroid. Okay, that works. It's a bit crap. I suppose we could.
Can you go in mod RS and add the max radius, importing it there, and then just do, if you do in mod.rs. You are taking everything from asteroid and publishing it.
Yeah, everything that is public.
So if you do create max max radius, is not working from there. Just create max radius. Is going to work or not?
That could work. Yes, it's just that it's not. I mean, I prefer to have asteroid there to specify that it's the max radius of the asteroid.
Up to you. As long as it works.
I suppose we can even do super at this point. Should work as well.
Okay, now I start to understand a little bit of that. We have to dispose of the spaceship.
So we need to dispose the spaceship. We don't need to do anything else, right? So we can just do commands ship spawn, and here we can just do print ln boom for now.
What happened when we despawn the ship to all the transformers that think that there will always be a ship? They panic?
I think those systems just don't get the ship anymore, which might mean they panic.
Yeah, when we do first, or when we destructor, and there is nothing in the query is empty at that point, they will panic. Let's see. Let's try.
I think it will panic. Yes. We need to add.
Now we have to register the system. Yes, I always forget that step.
Yeah, we'll need to do it in a plugin because it's.
Yeah, otherwise this is well. Then you have to do that in the plugin probably, but
at least it's in the same file.
yeah.
Here you keep jumping between the two files. Okay, let's run and let's make it panic. It did panic instantaneously, I think.
Because it spawned an asteroid on top of the ship.
Boom, panicked.
Yeah, we have to. We have to
let's
say
try
that.
again. Yeah, again.
Yeah.
Okay, now we got lucky. I just want to see. Okay, the collision is quite good.
Collision is quite good, yes.
Let's try with this one, which has a weirder shape. Yeah, a few pixels earlier, but still relatively okay.
We will make it that better. And yes, we are panicking where? In the unwrap, obviously, of line 75 of ship RS. What is there?
So let's have a look.
Ship RS line 75.
75. Yeah, exactly. This query single mute is unwrapping for us.
Unwrapping. And
I think there is an equivalent, which is query single mute or get single mute, which has a result. So here you will do something like
if
let all of that stuff.
Let some or some, I don't remember, my God. If let some this equal that, and then
and we do all of this.
And then we are safe against this kind of stuff.
That what it returns? Oh, it returns a result, so it's an okay.
Not some. Still complaining about stuff?
What is it complaining about?
It's returning everything in the first parameter. Add another round bracket after the okay. Okay, round bracket, and close it. And close.
That makes sense. Yes.
Was there. Okay. Cool.
Okay, that makes sense. Now it's still probably gonna explode because this is the rotation. We will have the same problem for the fuel cells, collision with the fuel cells. Like every place where we are querying a starship, we have the same problem.
If we didn't did a loop, yes. If we did a loop, the loop is just not starting. If we went with a single mute or single or stuff like that,
okay, let's see.
No, the collision with the fuel cell worked.
No, but then it crashes anyway because it's querying it somewhere else.
Yeah, it's true. Sorry.
Okay.
It worked because the ship is still there.
Where is the line?
155.
Oh, this one. HUD.
Ship RS 155.
But even this one, where we are getting this one, engine, this single mute, we need to do the same.
Same.
So get single mute, and if let
okay
of text.
Here we only have one.
Is it mute text? Yeah. And okay is lowercase. Okay, sounds good. Now we're still gonna fail with the fuel
ship
cell.
155. There was the next one. Let's see if you can touch an asteroid.
If you can die, please.
Please die.
Okay, this one was where?
Ship
39.
I know.
Why is still complaining 39?
Have you saved?
I think I did.
So try to go in ship 155. Just
ship
show me what.
155. Yeah, it's the same. Get single mute. Let if
let okay double round bracket and put every. You're jumping around a lot.
Too much, sorry. Okay, this is the same system we just created, basically. Now it's still gonna fail for the fuel cell. Which is Starship. Where is it?
Here it say add line 39. We already fixed that or not?
That's what I thought.
Go there again. Let's look again. Single. Query Starship engine single.
Oh, right.
We fixed the wrong one probably. The text will always be there.
Yes, you are absolutely
we fixed
right.
it on the wrong one. It's the engine that can disappear because the ship exploded.
Okay, so let's
rewrite
this guy. If
can't you revert with the ID with okay? If you go on the left, do your stuff.
Get single. And now the text is
text is a single mute.
We don't need the wrap.
Text. Yeah.
Because it's always there. And this guy.
Text selection 1, we have to bring it in. Okay. Let's see if now it's Zapier.
And now it should complain about the fuel cells.
I don't know. We will see.
Ship RS 136.
Probably is the fuel cell collision.
There you go. Collide with fuel system. So that's the one. If let okay. This guy.
Get single mute.
Okay, hopefully now we are okay.
Boom, nothing. And now we want a game over in the middle of the screen. But we can do that next time. What do you think?
Sounds good. So I'm gonna commit the stuff at the end of the episode so you can find it online. So I think that's all for today. I don't know if people have questions. You have 2 seconds to let us know in the chat.
The Python code is updated on the repository. Luciano will post it one day somewhere. This code is updated on his repository, always in the Luciano GitHub.
So let me post them here. This is one. And oh no, sorry. This is our old code where we do advent of code, which is still worth looking into if you're curious about advent of code.
And the new one is about to start. Don't forget.
This is the actual code we're working on, which is going to be updated shortly. Let me also put it on screen. And we have a Python version, I believe, called Pygame Fuel Tank, if my memory serves me right. So you can check it out there. And I think that's everything we have for today. Remember that all the repositories are open source, so definitely welcome to any contribution. If you know any better way to do the same stuff in Python or in Rust, please send us PRs or even just open an issue with suggestions. And yeah, until then, we'll probably see you next time which I believe is going to be next Monday. Still uncertain, might be next Wednesday. Let's see how things go. So stay tuned on Twitter and Twitch, where we are going to announce the next session. So thank you very, very much. Bye.